All right, so this is the calculator part of the review for the 3-1 to 3-3 quiz. Remember, we are rounding to the nearest thousandth for the AP Pre-Calc exam, unless we're talking about money, where we will round to the nearest cent, which is 2 decimal places. All right. So for the first problem, it says find the balance of an account in which $7,500 was invested. That's the principal. At an annual interest rate of 2.5%, R is 0.025, where interest is compounded semi-annually. This is n equals 2, quarterly, n equals 4, daily, n equals 365. The only other n that we sometimes see is monthly, which would be 12. Continuously, we use the continuous formula, PE to the RT. All right, so for this first one, the balance should be 7,500 times 1 plus R over N raised to the N, N is 2, raised to the N times T value. So find the balance. Oh, how many years do we have? I seem to have left that out. T equals 15 years. Okay, sorry about that. So to the 15th power. So T equals 15 years. All right, so I'm going to go to my calculator, which I'm using Desmos for this. Let me just split screen here. So we're not graphing anything, so I'm not putting in the A equals. I just want to make sure that I have this typed in correctly. Now, remember, I always forget this. When I want to type in 2 times 15, the multiplication keeps happening down here. I want it to happen in the exponent, so you do need to put parentheses around that to force that to happen. So go ahead and round this to the nearest cent, which is 2 decimal places. So after 15 years, the account balance is $10,887.10. Now, for the next one, the only thing we change out is that n equals 4. Otherwise, it's the same formula. So I'm not going to rewrite the formula. I'm just going to retype these two things in Desmos. So change this to a 4. Remember to change it up here too. All of your answers should be pretty close, just a few dollars difference with each change. And this would be 0.71 to the nearest value. Excuse me. And then daily. So daily, we're going to change this to 365. As n increases, the dollar amount increases. 10,912.29 will round up to 30. And I need to type in a different formula for continuous compounding. So 7,500 times e to the 0.025 times 15. All right. So 7,500 e to the 0.025 times 15. Oh, see, I did it again. I almost always forget parentheses there. So you just have to be careful. Double check. Look at what you're typing in before you write down the answer. Okay, so this is 10,912.44. The continuous compounding should be very close to the daily, just a few cents more in each case. All right, for the next one, this says $20,000 is invested at an annual interest rate of 3.25%, compounded continuously. How long will it take the investment to grow to $30,000? Round to the nearest thousandth and include units in your answer. So let's set up this equation. So we have an account balance this time of 30,000. This is continuous compounding, so that's the original 20,000 times e to the RT. So R is 0.0325, and we don't know T. Now, we could solve this algebraically, but we haven't officially learned how to do that yet at this point in the chapter. I know you learned about this in Algebra 2, but I want to remind you that we can solve by graphing as well. The hardest part about solving by graphing is just trying to see the equation. So the point of intersection, I mean. So let's see. All right, so this is y equals 30,000 and y equals 20,000 e to the 0.0325 t. And I guess if I'm going to put t there, I shouldn't make this y. I should make this like f of t. And what's wrong with this? Points are written like this. See what it's complaining about here. Okay, how about f of x? Oh, it doesn't like the commas. Sorry. Okay, don't type in the commas. I was like, why does it want those to be points? Okay, now I zoomed way out just to see the 30,000 and the 20,000 here. So let's take a look at this. You could also go to settings, by the way, and like manually change, you're trying to get into 30,000. So you could have said, change the Y values to 28,000. Oh my gosh. That off of there to 32,000 and, then click here to see. So you can adjust your window like that too. Anyway, I want the intersection points. And my answer is the X value or the T value here. So 12.478. No, 12.476. My eyes skipped a digit there. So time is approximately 12.476. What's the label on that? In these formulas, the time is always measured in years. If you do want to solve this algebraically, you would be dividing. Again, I haven't officially done this in class, reviewed this in class, so then you would natural log both sides. And then you would divide, this is 0.0325, and then you would divide by that to get this answer. But I would rather that you just solve by graphing. That's an important skill to have for AP Pre-Calc and AP Calculus next year. The 1986 explosion at the Chernobyl nuclear power plant in the former Soviet Union sent about 1,000 kilograms of radioactive cesium-137 into the atmosphere. The function f of x equals 1,000 times 1/2 to the x over 30 models the amount of cesium-137 remaining in Chernobyl x years after 1986. Find the amount of cesium remaining in the atmosphere this year. So this year is 2025. So first off, how many years after 1986 is that? So let's see. If I do 1986 plus 14, that gets me to 2000. 2000, so 14 plus another 25 years is 39. So I want to find f of 39. I do have a graphing calculator, so I could have also just done, let's X this out. I could have also just said, what's 2025 minus 1986? Okay, 39. So let's type in the function first. F of x equals 1,000 times 1/2 to the x over 30. That is how half-life formulas work, by the way. The half-life is 30 for this one. I would like it to tell me what f of 39 is. I don't need the graph to do that, so that's just right here. So 406.126. About equal to 406.126. What's the label on this? This was measured in kilograms. So this is how many kilograms would be in the atmosphere. An area with at least 100 kilograms of cesium-137 is considered unsafe for human habitation. How long after the initial explosion will Chernobyl remain uninhabitable for humans. So this is asking us to set the f of x function equal to 100. And again, solve for x. So again, we haven't talked about solving algebraically, and this is not a base E, so it's not as simple to do. So let's go ahead and graph this again. And if your window is crazy, you can set it back to like, let's just go to like back to normal. -10 to 10, -10 to 10. Let's just get back to basics here and see what happens. Okay, so y equals 100. And I don't know if I can do y. Let's see. Y equals 1,000 times 0.5 to the x over 30. Now remember, when we put in 39 years, we still had 406. So it's going to have to be way out past 39. And I do want the 100 to show. So there's the 100. If I just scroll out a bit, right there. So we will be at 100 when we get to 99.658. So x is approximately 99.658. X is measured in years after 1986. All right, so basically 100 years. So 2086, maybe we can start heading back there. Right? Find the nth term of the geometric sequence and the indicated term. So, all right, so remember how this works. This is a geometric sequence. You're told that. So to find the nth term, that's asking you to come up with the formula. So the formula in general is a sub n equals a sub, it's k in general, but we have the first term here. So a sub 1 times r to the n minus 1. So the first term I can see is, the first term, that I can see is 24. So that's the first term. And I get the r by just dividing two consecutive terms. It's got to be in the right order. So r is 72 divided by 24. And that's coming out to 3. R is also 216 divided by 72 is 3. But I'm told it's geometric, so I can just divide the first two and call it a day. So this is 3 to the n minus 1. So this is our nth term, or our general term. And then find the indicated term. So now use that to find the 15th term. So that's going to be 24 times 3 to the 15 minus 1, so to the 14th power. And we are definitely using a calculator for that. So that's just 24 times 3 to the 14th. All right. There's nothing to round here, so write all of these digits down. So the 15th term is, let me get this written down and then I'll figure out what number that is. Throw some commas in to make it easier. Yeah, so 114,791,256 is the 15th term. All right, take a look at the next one. So for the next one, the first term is 15. The r is -5 divided by 15, which is -1/3. The negative sign matters. It has to be there. And so the nth term, or the general formula, is 15 times -1/3 to the n minus 1. And this time I want the 10th term. So the 10th term is 15 times -1/3 to the 10 minus 1, so to the 9th power. So let's see what that comes out to. I'm just going to change out my numbers here. That was 15. This was -1 divided by 3. Oh. And this was to the 9th power. And I would like this to be a fraction, because if I round it to a decimal, I guess -0.001 would be okay. But this changes it to a fraction, so I like that better. So -5 over 6,561. So -5 over 6,561. So I have this little summary for the calculator part. I know both compound interest formulas and can use them to find a balance after a given time. I can solve an exponential equation by finding an intersection point on my calculator. These are the two calculator skills that you need to know for the calculator part. All right. The rest of this review can be found on the next video, which is the non-calculator part.